Welcome all to a session on automata theory and computability. In this lecture video, we will learn about derivations and parse tree with respect to context-free grammar. Okay, so we have already seen in the previous lecture video about derivation, right? When we wrote a context-free grammar for the given context-free languages, we have seen some examples where we applied the rules in context-free grammar to derive a valid string, right? And I had mentioned that there are two kinds of derivation, leftmost derivation and rightmost derivation. So we will look into that those concepts in detail in this particular lecture video. Okay, so when I talk about derivation, there are two kinds of derivation. One is leftmost derivation and rightmost derivation. Okay, so to get a clear idea, we will take some example, and this is the example what I took, this language where it is defined as an bn concatenated with cm, where n and m is greater than or equal to 0, and this is the grammar, this is the solution, context free grammar. And okay, so let us take some example of a valid string that need to be generated from this. Okay, so I'll take AABB followed by 3C. Okay, yeah. So this is what I want to derive, okay, from this particular grammar, and I can derive this string by applying either leftmost derivation or rightmost derivation. So first let us look into leftmost derivation. Okay, okay. Okay, now I want to apply, I want to get this string, right? AABB and followed by 3C. Okay, so obviously we have to start with the first rule or the starting non-terminal, which is SQs NC. Okay, and the rule applied here is SQ. So this is the rule applied, and this is the derivation. Okay. Okay, so what is leftmost? See, now you want to expand these two, right? Whatever I obtained here. So I have two in this case, I have two non-terminals, right? And if I want to derive this string, then obviously I have to substitute this non-terminal with the right hand side of what this non-terminal gives, right? Now I have two options here, n and c. So which one I have to substitute first? So according to leftmost derivation, I have to substitute the non-terminal that is leftmost in the rule. Okay, so among n and c, n is the leftmost, right? So this is the leftmost. So what I will do, I will expand the derivation by substituting the leftmost non-terminal in the grammar. Okay, in the rule set of the grammar. So I will replace, or I will substitute n with a and b, right? So this to obtain 2a 2b followed by 3c, I will substitute n with a and b. Okay, so this is what I got. Okay, if I substitute n with a and b, and c will be written as it is, right? Okay, now okay, still I have I didn't get the derived string or the valid string what I wanted, right? So in this case also I have two non-terminals appearing. So which one should I substitute? Again I have to substitute the one that is leftmost. I have n and c. So among these two, the leftmost is n, right? So I will again replace n with a and b. Okay, so here I applied the rule a and b. Okay, the same rule is applied. So a will be written as it is, and this n will be replaced as a n, and c will be written as it is. Okay, so the rule applied is a and b. Okay, again I have two non-terminal. Now I got the two A's and two B's what is required. So what I can do with this n, I have to substitute it with one of the rule, that is n gives epsilon, such that n is vanished from the derivation part, right? Okay. So n is again substituted since it was leftmost by applying the rule n gives epsilon. Okay. Now I am left with only one non-terminal. So what I can do, I can simply now there is no concept of leftmost or rightmost since I have only one non-terminal. So I have to substitute C. Substitute C with C gives small letter c followed by non-terminal capital C, right? Okay. Again I have to apply the same rule. So this C is replaced with small c followed by capital C. Okay. So I require one more C. C capital C. Okay. Now I got the 3C what I wanted. Now what I can do, I can simply remove this non-terminal by substituting it to epsilon. So the rule applied is capital C gives epsilon. Okay. So this is the string what I wanted, and this is how I obtained this string by performing leftmost derivation. Okay. So this is about leftmost derivation. So where I apply or where I substitute the leftmost non-terminal in my grammar, in my rule, right? So, okay. Now let us see rightmost derivation for the same string. Okay. So yeah, I'll make use of different color. S gives NC. Rule applied is SQNC. Okay. So if your guess is that I have to substitute C first, then you're right, because among N and C, which is the rightmost, in this case the rightmost is C, right? So I will substitute C first. Okay. So this N will be written as it is, and C will be replaced with small letter c followed by capital C. Okay. Rule applied is again among the two non-terminals N and C, I will again replace the rightmost non-terminal, which is C, with small letter c followed by a non-terminal C. Again I will replace C with small letter c followed by a capital C. Okay, so I got the 3C what I wanted, right? Now I can eliminate this non-terminal by substituting it to epsilon. Okay, so this is what I got. Now what I will do, now I will apply, or I will replace this N with A and B, and this is what I have, what I get, right? Okay, then again I will replace this N with A and B. N gives A, N, and finally I will substitute this N with epsilon such that I get AABB followed by 3C. So N is substituted with epsilon. Now, even now, I was able to generate this, right? AABB followed by 3C. Okay. So irrespective of leftmost or rightmost, I was able to derive this. So if you apply any rule, you should be able to generate a valid string if the grammar is correct, if the rules written in the grammar is correct. Okay. So this is about leftmost derivation and rightmost derivation. Now we will look into the concept of parse tree. The grammatic structure of the string is captured by a kind of tree called as parse tree. which is basically a pictorial representation of the derivation of a string from the context-free grammar. Okay, and this parse tree records which rules were applied to which non-terminal during the string's derivation. And we will be learning about this parse tree in the concept of parser, okay, which is um, a concept in system software and compiler design, which you'll be learning in the upcoming semester. And in this lecture video, we will be taking a small baby step into knowing what exactly a parse tree or how it works. Okay, so in depth we will be learning in the upcoming semester in the new subject, that is system software and compiler design. Okay, so we will learn how to represent a parse tree by considering the previous example. So I have this rightmost derivation, right? And for this we will write a parse tree. Okay, so since it is a tree, we know that tree contains leaves and root, right? The root of a parse tree will always be a starting non-terminal, that is S. Okay, and leaves of this tree will be the terminals, okay, or the symbols that appears in the string, or it can be epsilon. Okay, and what about the intermediate nodes? That will be nothing but non-terminals. It can be a starting non-terminal or any non-terminal that is part of the grammar. Okay, so let us write the parse tree for this. For this rightmost derivation of AABB followed by 3C. So as said, I have to start with the root, which is S. Okay, and which rule was applied first? We made use of S gives NC, right? So this is the derivation what we applied, right? To derive this AABB CCC, right? Okay. So S gives NC. So this is the rule what we applied, S gives NC, right? Then what did we apply? We expanded this C, right? So C was expanded as C gives a terminal C followed by a non-terminal capital C. Then again, this is with respect to rightmost derivation. So again we expanded this C, giving small c followed by that is a terminal C followed by a non-terminal C. Again we expanded this as small letter c and capital letter C. Okay, so these three are terminals, the symbols that appears in the string, and this is the non-terminal. And finally this C non-terminal was evaluated or expanded to epsilon, right? Okay, then N was expanded or it was substituted to A, another non-terminal N followed by B. This N again was substituted as A, N, B, and finally this non-terminal N was replaced with epsilon. Okay, so if you observe, all the root nodes, all the leaves are terminal, right? So these are the leaves which are terminals, and the intermediate node are the non-terminal that appeared in the derivation of the string, right? And the starting non-terminal, that is the root node, will always be a starting non-terminal, yes, right? So this is about writing a parse tree for the derived string, right? So in this case we applied rightmost derivation, and sometimes, so if you apply leftmost derivation for this string, you'll get the same parse tree, but it is not necessary that I need to get the same structure of a parse tree if I perform leftmost derivation or rightmost derivation, and it is okay to have different structure for leftmost derivation and rightmost derivation. Okay, and we will learn how the grammar is ambiguous with respect to its parse tree in the upcoming lecture video. Okay, so this is about the two kinds of derivation and parse tree representing derivation using a parse tree for the given grammar. Okay, for the given valid string belonging to the grammar. I'll see you in the next one. Thank you.